Hey, good morning. We're going to talk about network attacks, land attacks, and security. It's time for networking, routing, and switching. Okay, so MAC address attacks. Right? What do we have? This is There are several different security concerns. We've been talking about security, and we have this thing called a MAC address table, otherwise known as a CAM table. What's that CAM table? All right, this is a device that is in our switch. It is technically the whole component. It's the brain of the switch. Right, so you got to think about it in terms of the brain of the switch. Right, if I have a table, in this case, it stores um, information, all right, about my devices that are connected. Right. This is here's my here's my example, right, of my MAC address table. Okay. And remember, this is the one thing that actually makes a switch a switch. If I didn't have this table, what I would really have is a hub. And so the idea of attacking my switch directly is this concept of um, can I turn it into a hub? And that's essentially what will happen in a direct MAC attack. Is that not a Big Mac attack, right? that's uh, that's what happens when you just need to get some get some McDonald's, right? And I have that a lot. I have Big Mac attacks. Um, but but yeah, um, when you start to fill up that cam table on the switch, what will happen is that it will at that point become a hub, and so we'll broadcast things. So the idea is that um, if I do that and turn that switch into hub, I'm going to be able to snoop and get frames that I shouldn't normally be able to see. So if what kind of things could I capture? Right? Remember, I could capture ARP requests. I could capture I could capture trunk traffic, right? And so and in this case, there are tools out there that can actually take that information, and I can flood the switch just a few seconds, and I have overcome that switch's uh, ability, right, to keep that table updated. And so, what do we do? And that's port security, right? So, how many source MAC addresses can be learned, right? Maybe I just want to say one. I just want, okay, the only thing you can do is, and here's the security point of this. If I plug a device into a switch, that switch goes ahead and puts the MAC address in its configuration, right? And now I will only receive frames from that. So if I take a device and I plug a different device in, like say a laptop or something, it's into that port. The port's going to shut down, or it could create a warning, right? So that's what port security does. It gives me some options on how I handle specific things. Now I could actually put two or five or some other number of addresses in there. and that way it would allow me to do some changes because I don't want to hobble, myself, or I have to reboot my switch or reset my port, for instance. But it does give me the ability to have a reasonable number of MAC addresses in my table before I start to think something's weird. Okay, so that's kind of what happened there with that, and so um, that is the idea of attacking the switch directly. The other thing we have is where the switch is used as the medium of attack, right? So this is called a LAN attack. And let me get that up here. And so yeah, so at this point we have again MAC address attack where we have direct attack on the switch's CAN table, and then we have this LAN attack. And there's several different LAN attacks that are available that can happen, and we have to actually mitigate some of those. So these are things features that are built for the switch, right, so that I can try and mitigate some of the attacks. So two here are VLAN attacks and DHCP. So DHCP, remember, is VLAN first of all is a pretty secure method of communicating. It's extremely secure. I mean, there's no way around that one. If I can control at a physical level which type of packet gets passed based on a tag that's inside of it, I am actually executing a lot of power over what can travel over my network. Right? And so the first thing is if I were to lock down my entire network based on VLANs, and that happens many times in networks, somebody's going to try, right, to exploit, right, that tool. So if I had a threat actor, okay, that's what we're going to call him. That's the guy in the black hat there, okay. So the threat actor, right? What I'm trying to do here in this VLAN hopping, okay, is I'm trying to fool the switch into trunking with me. So normally when we set up trunks, and remember when we talked about trunking, there were certain modes that we could set the switch on to where it would automatically trunk. So if I had a mode like that on, and if I received some information from a host that was acting like a trunk, and this is basically what we're doing is we're actually trying to exploit possible misconfiguration of the switch. Okay, so if I were to send out a trunking protocol, dynamic trunking protocol frame from my laptop, right, or from my device, what I'm trying to do is I'm going to fool that switch into thinking that it can wake up and, oh, now let's trunk. So what happens when we trunk? Remember, when we trunk, then we can actually utilize or we can actually see the packets that are flagged for other VLANs. Right? That is, if we have our trunking set up so that if our trunking is set up in such a way that those particular VLANs are accessible, right? And so, let's see here. Okay, so if the VLANs are actually accessible on the trunk, then and if I fool the switch into thinking that I can trunk with it, now I get to see packets that were not intended for me, right? And so that's the idea there. So then I can actually tag traffic to go on another VLAN, and I can basically move between them, right? So effectively what I'm doing is when I do VLAN hopping is I'm fooling the switch to think that I'm also a trunked switch, okay? Now another attack is VLAN double tag, right? And so the idea there is that that what I have is I have some I I go ahead and put native VLAN tag in my packet, and I embed inside that another VLAN tag. So once that goes through over the trunk and the switch actually thinks that it's passing trunk traffic over, the next thing that happens is that it sees the other VLAN tag in the packet, and it goes, oh, okay, well this packet's really destined. So the next switch will see that tag and actually pass it on as if it is destined for another VLAN. So I can send information that way and basically hop VLANs that way as well. So it is a problem, and the idea is that what I want to do in this case, in order to make this, it's all about configuration, right? I got to think about what I'm doing. So the idea is that, okay, if I have this feature on the switch, right, that allows me to turn on trunking on a particular port, what I want to do is make sure that I have trunking off on any access ports. All right, so I don't want to have a setup to where I have gone on and allowed trunking if the other port can trunk, right? And so I want to just disable it. It has to be manually turned on. And also native VLAN, right? Only for trunks. So remember that when that switch is in a default state, it's native VLAN and default VLAN are all the same, one. So that's why what I would do is I would actually change the native VLAN to a different one, and I would specifically set those trunk links to have a different VLAN number, right? And I would also make sure that I don't have, like it says here, some trunking capability on an access port, right? So what that forces me to do, right, when I look at a switch, okay, and I think about this switch, no matter what it is, right? Now let's just look at this. Sometimes just an image of the switch, and you see it, right? And you think, okay, I got this switch, and I'm going to show it here, just kind of give you this idea of what that looks like, right? I got this switch here, and when I think about designing my network from a security perspective, okay, I'm going to actually look and see, okay, these are uplink ports, right? Or these ports I'm going to use them as ether channel ports. Right? These ports are going to be for access level ports, right? I make a specific plan in my design based on what I want to do, and keeping these security characteristics in mind. Right? It becomes a point of just being sure that you know when you design your network what you're going to do. And if I don't know that, if I don't plan it ahead of time, then I get to a point where I'm just making configuration changes to accommodate something, and the chances are that I'm going to leave something out, right? And that happens a lot in real life. I mean, we try to accommodate changes, and we have to go through and think, well, hey, what's this going to impact when I make a change on my network? And I hope that I'm aware of the network enough that I can come up with all those things. So a lot of times that's why you want to have a team of people, right? So that if I think about impacting changes, I can look at my team and go, okay, what is going to change here? What do we need to worry about? And so hopefully somebody on the team has remembered their Cisco switch training and can think, oh, what about hop in VLANs, right? What can I do if I had the wrong software installed on my access port? Right? So is my switch configured properly to prevent anything from trying to trunk, right, with the switch, right? So that's the idea there, and just continually thinking about what what options are out there and what it means for security. DHCP is another thing, right? I put some software on my machine that sends out broadcast requests, right? Looking for DHCP servers. Here's the deal: if I know that I have a device that is gonna look for DHCP server, if I can spoof that, if I can offer some other alternative, right, faster, if I can intercept that DHCP request, then I can control what that device sees as the gateway, or I can give it any other information like DNS servers, right? So maybe I send it the right gateway information, but I give it the wrong DNS servers, and those DNS servers have a spoofed website for Google. Imagine instead of seeing Google, right? So here's the idea of that. Instead of seeing Google, so here's my DHCP message that comes down to my host. Inside that DHCP message is a DNS server that points it to, maybe it points it over to me, right? Right, whatever I am, right, whatever I am. So I'm pointing to, so I'm telling my device, hey, send your DNS requests over to me, and I'm going to fulfill them. So what might happen here is now that this is my bad actor, right? So now my bad actor is over here, and it's receiving DNS requests from the host, and my bad actor forwards all of them to regular old Google, and it works, right? Except for whenever it gets a request for Google.com, it sends back the DNS for that site, right? And so this is just an example, right, of what could happen. And obviously, G00G.lee.com is not Google.com, right? Or I could just go ahead and I'll just stuff a DNS packet with whatever I want, right, in there and forward it to whatever I want. So now my user opens up their browser, the browser goes to Google, and we can get as creative as we want to here in this case. And remember, ultimately what I'm trying to do is I'm trying to use attacks to trick people, trying to use attacks to achieve more. And so I want to trick someone into clicking a link, right, into putting a security credential into a box they shouldn't put it in. I want to capture um, an email address, right? I want to send a bogus login page to a user and capture their credentials, right? Maybe I'm a red team hacker, okay, on the campus on a remote site, and I'm trying to get in and test the security, and I want to get this fool the CEO, right, into giving me credential. And this is another reason why, just to say here, your CEO of your company does not need to be the king of everything, right? So think about that. When you're in the IT world and you have a small company and the CEO says, "Oh, I need to have access to everything. I need to be administrator of everything," right? This is where you stand your ground, right, and explain to them, no, no one needs to be administrator. We could have that login, but you cannot use it, right? You can't use it to log into things, um, because the one time you mess up, right, the one time you fall for a trick, the one time your credentials are exposed, and at that point you have, especially if your CEO or your head guy doesn't even know, right, that his credentials got exposed. Right? That's the way it really works. Is that you don't know that you exposed your credentials, right, to some threat actor, right? It's always a glitch, right? It's always I don't know what happened. It was some weird event, right? It's always a glitch. So anyway, this is the way we that an attacker basically begins to build on this. So can I trick a device into accepting my DHCP message, into giving it some other DNS server, giving it some other information, and then it goes out and tricks someone else, right? So, DHCP starvation, a little bit different. What I'm trying to do in this case, this is an attack tool called Gobbler. I'm going to try to lease all of the IP addresses in the DHCP range, and just make tons of them. It also could end up filling up an ARP cache, right? And so if I were to utilize that, I'm actually what I'm doing is I'm making that DHCP server unavailable for legitimate requests. Right, so what will happen is that eventually the DHCP server, it gets full. It has a whole bunch of leases. So let's just say that in order to really think about how this attack might work, is let's say that we had a DHCP server and it was configured to have a default lease time of 7 days. So then I flooded that server with bogus requests. And it went in and actually gave me, maybe I had a pool of, 1,024 addresses. Okay. So then I went in and started flooding this server with bogus packets. And, I don't know, 1,000 of them were taken up by bogus requests. So what happens over the next 7 days? when all the DHCP leases that exist begin to expire of real devices. Now, normally, what happens in a DHCP server is that if a client is acting on good behavior, in most cases, it's going to ask to release the IP address that it's already had. And so the DHCP server will accept that, right, and it will continue. So if you've had internet, if you've had network access or an IP address on the network, you're going to keep it, right? But the idea is that new devices, right, or ones for some reason that maybe they were powered off and powered back on, right, they cannot get DHCP leases. And so you end up getting, maybe you end up getting all these phone calls, right? My internet's not working. Right? I can't get out on the network. I can't communicate with my network server. Then all of a sudden, right, you wake up and you have a quote network nightmare, right? And that's kind of what happens is all of a sudden I have this nightmare, and oh my goodness, we don't know what's going on, so we have to start troubleshooting. And if we troubleshoot incorrectly, then we could do some things that could just be a wrong move, right? If I don't think about checking things like this, my DHCP server, right, that had its table full of bogus IP address leases, I could go and troubleshoot some other issue, and end up basically painting myself in a corner, doing something wrong. So these things are just an ability, right? If I want to turn on the guard, right, so that I cannot actually, my switch won't allow me to spoof a DHCP server or flood it with packets. Those are good things, right? Those are good things. So these are things that we don't necessarily always think about. But they're good. And thinking about the way the network functions at the layer 2 level can prevent a lot of things from going on that affect other levels of the network. So there are some other attacks in the material you definitely want to look at. One thing I want to show you is the CDP reconnaissance, right? And so this is Cisco Discovery Protocol, right? And every device has it turned on, right? We can actually see information. So when I have a Cisco Discovery Protocol enabled port, notice that this information gets sent out in periodic, unencrypted, unauthenticated broadcasts. So if I have a device that is able to intercept this information, I can find out about the status of my network. And so what you want to do is you want to turn off Cisco Discovery Protocol when it's not being used. So on an access switch, right, I would turn off CDP. So this is global, no CDP run. And when we say to disable something globally, that just means we're going to turn it off on not only every port, but just the device itself. Right? It's not running CDP. Now, if you're gonna have a Cisco switch, for instance, that connects to other switches, in terms of trunking, right? If we trunk between two switches, then we want to actually utilize a switch to find out about its neighbors, right? It's not necessarily always advantageous to turn that off, right? So there's going to be a lot of times in IT when you are going to see these security um, features, so to speak, and you're going to think, oh, I need to do that for security's purposes, right? But then you think, oh, it's going to make things complicated, right? And it is complicated. So there could be definitely a valid reason for not using that, right? I don't necessarily want to turn CDP off, right? But I may want to turn it off on port by port basis. So I can do that. But you got the point is that there's not necessarily there are best practices, but there are not necessarily rules that you must follow. Right? You have to make your own decisions based on best practices, based on your network needs, and just understand that there are sometimes things that cause risk. And so that's the idea, is we have to do risk management. Okay. So we look at CDP. We also have LLDP, Link Layer Discovery Protocol. This is the open source CDP. So notice that LLDP is different commands. No LLDP transmit, no LLDP receive. Right, so I could actually turn it off one way and not the other. Right? On the CDP, it's either on or off. Right? It's either on or off. But I can turn it off on the switch globally and the port. So it's just a different implementation of both. Now, there are certain devices out there that you might find when you have CDP that actually it doesn't necessarily, it's not a native Cisco device, but it can understand CDP. So you might see that out there in the world where you can actually turn that thing on or off and utilize Cisco Discovery Protocol. I think Ubiquiti is a manufacturer that does some of that. But this is just an overview of security. Definitely not a total replacement for the module, but I wanted to give you some good information about some things that are in that layer 2. Just remember, security is something that happens in every network layer, not just the IP layer or the transport layer, right? Every layer. So the layer 2 security model that we think about is where we actually do the switch configuration in a way. The layer 1 security model is, can I physically control access to my switch? All right? Can I control it in a physical way? All right? And so that's that layer 1 security model, right? But there's a security model to every point, and I want to thank you for your time, and I look forward to your questions. So be sure and ask questions about what you have heard today. Until next time, this has been Networking, Routing, and Switching.